Hello again. I'm Paulo Shakarian. Welcome back to the Neuro Symbolic Channel. So today I'm going to provide a little bit of commentary in light of Google's AI overview. And just to give a short history, earlier in May, Google released this AI overview feature to its search, in which a large language model would summarize the search results for the user in a way where, hey, maybe you can just read the summary and kind of get the gist of what all the results are about. Now, what happened over the course of the month, many people started noticing some very weird and bizarre results. Uh, and the source of the cause of these, probably vary greatly. Everything from the large language model regurgitating a parody article from something like The Onion, to people trying to game it to get it to say weird stuff. But anyone who's used it, including myself, there were some very weird things that came up over time. Many of us would think that, hey, why didn't Google test for this? And just yesterday, Google released a blog post where they talked about these odd results and what they're going to do. And this is a really interesting comment and tells us a lot about what probably one of the world's greatest software engineering shops struggled to do, and that is address this problem of what we call hallucinations in large language models. And Google thought that, hey, we can just simply out engineer it. We can do a lot of testing and overcome the problem. And the issue is that even if you do that, you're never going to resolve the problem. And even if you could quantify it and you could get it down to a fraction of a percent, something like Google search that has billions of users, that small fraction of a percent is going to be hundreds of thousands of people who will get something very, very weird. And being that Google's a big company, those people are going to quickly spread that on the internet. There's also another issue in that it's not just that there's a large user base, is that the distribution of search terms within Google is known to be something that changes significantly over time. So any test that even Google does that would be very thorough is not going to capture how search terms evolve over time and how some weird new topic that may emerge in popular culture may lead to some outlandish result of the AI assistant. So, in the blog post released by Google describing this, they talked about some of the strategies that they're looking to mitigate. And basically, they're saying, hey, this is going to be more engineering. We're going to detect patterns that the large language model normally gets wrong. We're going to limit the content that it's going to provide these AI overviews for. But honestly, at the end of the day, that's still a band aid. And they, finding these patterns is very similar to the kind of testing that they've done, in that it relies on kind of historical backward looking knowledge of what people typically will search on. And again, there are way too many people in the world, even for Google's engineers, to anticipate every possible search query. So then how do we address this, fundamental problem that language models are going to hallucinate and provide weird results, and that people will always see this? Well, there might be some people who will still say that, oh, well, if we just have larger and larger models, then we'll overcome the problem. And there is there's nothing that can support that. And the issue really of why having just a larger model will not necessarily reduce hallucinations is for several reasons, but one that's really easy to understand is that if it's just sucking in a lot of data from the internet, which you need to create a larger model because you're not going to have annotated data to get that kind of scale. Annotated data is a non-starter. You're going to inherently bring in a lot of data that's bad or purposely wrong or fictional and so forth. So that's not going to solve the problem. Another possible solution is increasing the size of the context window. And I think this is something that is going to probably significantly improve LLMs. And for those of you who don't know, the context window, the size of the input, this has been historically the key bottleneck with the transformer paradigm because it's what you call in computer science a quadratic operation, which is computationally expensive. And for those of you who aren't, uh, super technical, this is also why you see like slow results being generated by ChatGPT compared to other pieces of software. Well, Google in particular, and I'm sure its rivals such as OpenAI, are doing a lot of research on how to expand this context window size, come up with a bunch of engineering tricks. And this may reduce hallucinations because you have maybe more homogeneity in the information that goes into the prompt and is used in the training data, but it still doesn't, it still will not be guaranteed to resolve this issue of hallucinations. Because again, we're relying on massive amounts of data to train these things. And there is really, you can't be assured that this is going to even make a dent in the problem. So, what can make a dent in the problem? Well, one of the big approaches out there with large language models is to have a quote verifier that can take the output of the large language model and verify it against some factual knowledge base. However, here we run into that you have to have this factual knowledge base. And if you rely on, say, a very large knowledge graph, uh, there are issues in creating such a knowledge graph and maintaining it and making sure the data is clean. That's not to say it's not impossible, but is it realistic to assume you're going to have a large enough knowledge graph to truly be able to validate everything that comes out of the LLM? And if you could, why would you not just create a technology that can query the knowledge graph in the first place to come up with all your answers? Maybe use the LLM as an interface. Now, this is not to say that there's not researchers who are looking into this type of thing. In fact, there are many. At ASU here, we did a natural language processing search for a new faculty member. And through that amazing process, I got to meet a lot of great young PhDs who are actually looking at this very problem. How do you have this interface between a large language model and various symbolic solvers? And indeed, we'll have some more videos in the coming weeks where you'll see some of that type of research on the channel. But this is still, I think, in its early days. And it also, there's still a lot of challenges with maintaining and curating very large knowledge graphs. And um, this is not to say that the people who do work in this area haven't done enough. I think it's more the fact that there probably should be more grant funding put toward this and maybe more of a focus on industry put toward knowledge graphs. Nowadays, especially lately, there's been a lot of focus shifted to large language models. What about these other technologies to support it? But at the end of the day, even as you investigate ways to address these hallucinations that came up in, the Google AI overviews and many other things for that matter, is they are part of what you get with a large language model. The reason that we have large language models is because through semi-supervised learning, you can push through a lot of data and do next word prediction and achieve a lot of scale doing that and throw a lot of money into training and hardware and energy and create these big models. And you don't have to worry about the human cost of labeling data and looking at huge amounts of data. It's not even possible for humans to label internet scale data and have it be done in any reasonable time frame. But because of that, you also really can't make guarantees on the output. And so this is the fundamental issue. And in many ways, this is something really new to the software industry, which for years and years has been able to generally verify that its products work. And when a bug was identified in its product, they could isolate that bug and they could eliminate it because overall the system is basically deterministic for both input and output. Language models, since we're talking about natural language, we have a lot of non-determinism. And so I think, solving the problem of hallucinations is going to continually be a problem for these big companies as they roll out products. And it's going to definitely be a factor in determining what the addressable size of the market is in terms of who can tolerate levels of errors from the large language models due to hallucinations. So anyway, that's it for today. Just wanted to give some commentary. Thanks much.